Hello, everyone. After the last talk, it set a high bar, so I'm going to do my best. We're going to talk about certificate transparency today, and we need to learn what it is. First of all, this presentation is brought to you by two industry leaders, Let's Encrypt and Clearly myself. I'm Antonis. I come to you here from Zurich, from Switzerland. And I am currently unemployed since March or something, where Google laid a few of us off. So I just have a lot of free time to give these presentations. I enjoy networking a lot. I have an autonomous system with over 1,600 BGP neighbors with presence in Europe. And I'm looking forward to one day coming to London as well. So to increase my footprint, as they say. Let's talk about a few layers above. Networking, we're focusing on HTTP today, which is probably a large part of the IP traffic going around the internet today, and specifically about HTTPS, which is the secure version of that. HTTPS adds a few guarantees, like you're talking to the real server, and nobody can change the data or can read the data. Here are some statistics from Mozilla. You can see here that most of the pages being loaded today are over HTTPS. They report over 80%, and in some countries over 90%. This is due to a lot of great work that has been done by many people, including all of you probably deploying HTTPS for your websites and your services. Google Chrome has similar metrics. They're a bit better. 93 to 99% of the websites being loaded with Chrome are currently encrypted and the users are protected. And most of their time is being spent using encrypted connections, which is great. However, it also means it's very important, and we have to get it right. And this requires some work. In order to secure HTTPS, we rely on something called TLS. TLS is basically, it is used in other places as well to secure email. It has many applications, but it's also used on the web. And in order for that to work, we need some certificates. Basically, we need a way to tie some cryptographic keys into the identity of a website, the domain name. And because we cannot have this mapping into every thermostat and every mobile phone, we rely on these hierarchies of certificates. We have like a few hundred root certificates, and then they delegate their trust down to the final certificate that the website is using. So because this is used on the web, this is called the web PKI. Because this is a networking event, we're going to compare it to RPKI. If you've heard about that. The way it works is that you just go and you download every hour or so, you download all the active certificates that are out there, and then you do some processing on them, and then you send them to your router, and the router can do filtering. The web PKI works differently. Every time your browser connects to a web server, it just gets a certificate specific to that connection. And if you connect again, you may get a different certificate. So there is a difference in the way it operates. And to get some ideas of the size, it is significantly larger. There are almost 5 billion certificates that have been issued. And over 500 million of these certificates are currently active and unexpired. They're being used by websites or services or mail servers or whatever it is. And every single hour, we issue over 250,000 new certificates. So every hour, we have more data than RPKI. So due to the large size of this ecosystem, it's a bit more difficult to ensure that everything is in order. Because there have been times where either due to someone keeping a default password somewhere or actually having malicious intent, someone gets control of these 100 or so keys that are very crucial to the entire internet, and they do bad things with it. There is this Dutch certificate authority whose keys were compromised, and they were being used to intercept and change Microsoft updates and read the traffic of google.com, CIA.gov, and similar other high-profile websites. So people are after those keys. They need to steal them, and they can do a lot. They can decrypt all this 99% of the traffic with these keys. So we need to make sure that they cannot get these keys and they cannot issue certificates for any domain they like. Only the legitimate owners can do that. So we need to find a way to police this ecosystem, basically, of CAs. And so this is why certificate transparency was created. We're trying to create something similar to the RPKI model, where you know every certificate. We create those buckets. They are called city logs. And in these buckets, we add all the certificates that we know of that have been issued, and then someone can go and look at them. So if you have a domain name, you can go into that bucket and look for information about your domain or your website and see if a certificate has been issued. And if you know about it, like if it's something you did or if it's something someone else did. So we're trying to aggregate these billions of certificates into these buckets so we can go over them and make sure everything is happening according to the rules that we have set. And you may say, like, if someone hacks and gets a private key, they steal it somehow, why would they publish their certificates there for everyone to see? And the reason is that browsers like Safari and Chrome, they will not connect to a website unless you do this. If you haven't made everything public for everyone to see, the browsers will not finish the TLS connection. They will not exchange any data. They will say this doesn't work. And even other browsers like Firefox that don't do this, they still benefit from it because everyone has to do it for Safari and Chrome. So they can get to look at these buckets as well and make smart decisions about which these 100 or so organizations should be. Is someone misbehaving? Should we remove them? Should we add someone else instead to provide certificates? And this is helping significantly. There are currently 6 companies that are operating these data buckets, these city logs, and they are here. And from one of them, from Let's Encrypt, we have Phil with us today, who's going to tell us about what does it take to operate one of these city logs. So Phil, are you there?
Yes, I am. Hi, everybody.
Great.
I'm coming from Detroit, Michigan. So you all get to look at my ugly mug up here on the wall. I'm going to talk about how Let's Encrypt operates reliable CT logs. So myself, my name is Phil Porada. I've been working at Let's Encrypt for 6.5 years now. I'm a software engineer, previously site reliability engineer, aka systems administrator. I get to help build and maintain parts of the web PKI that Antonis was talking about. And at night, my real job begins. I'm a super dad. I change diapers, give piggyback rides, and tell my kids tales of infrastructure to bore them to sleep. Next slide. So what is Let's Encrypt? Let's Encrypt is a nonprofit certificate authority that provides TLS certificates to over 325 million websites actively. And we make it easy to get these certificates for your browser to say HTTPS free of charge. Primarily, we're supported through corporate and non-governmental sponsorship. And to date, Let's Encrypt has issued almost 100 million certificates for .uk domains. And of those 100 million, there's about 7 million currently active certificates just for .uk domains. Next slide, please. So we've written about certificate transparency in the past, what it takes to stand up a log and run it and maintain it. This presentation is going to be a slight rehash on those blog posts, along with a few improvements we've made since they've been written. Next slide, please. So how does a CT log benefit a certificate authority? Well, Let's Encrypt is both a certificate authority and a certificate transparency log operator. It helps us take control of our own destiny. There are some industry mandates that we have to follow. Every certificate we issue is called domain validated. That determines the type of information that can go into a certificate. And each domain validated certificate must be sent to at least 2 distinct certificate transparency logs run by different operators. So Let's Encrypt or Google or Cloudflare or Sectigo. No 2 operators can have control over all the information needed. And then for different types of certificates, like organization validated or extended validated, the number of distinct CT logs required increases. And so Let's Encrypt typically issues over 3.5 million certificates a day. And we had to set out to build a CT log infrastructure that could support that high volume and the volume of all the other certificate authorities currently in existence. Next slide, please. And so there's CT logs, and then there's another concept called shards. And each Let's Encrypt certificate transparency log is made up of individual temporal shards, named after a period of time. Each shard is technically a separate and distinct CT log that shares a particular family name, such as oak, which is our production log, or sapling, which is our testing log, where we test infrastructure changes and also throw super high volumes at it, trying to get it to break. So it makes sense to conceptualize shards as belonging to a single log. And when you see any kind of communications out there on the internet, logs and shards, pretty much the same thing. Next slide, please. So here is the current architecture that we've been running oak and sapling on since about 2019. It's evolved a lot since we initially set out to build and deploy these shards. The image in the top left corner is just a little graphic showing how we run our logs in Amazon. We run them all in Amazon Web Services. The picture on the right shows an evolution of how our database used to be to what it is now. We previously had every shard in a single database instance and quickly ran into problems and fixed them so our logs wouldn't be disqualified, meaning turned unusable to certificate authorities. Primarily, the software we run is Google's Certificate Transparency Go, another product they have called Trillion, and etcd. Amazon handles some aspects of the database for us with their RDS service, but we're still responsible for all of the performance tuning, database migrations, and monitoring of these various applications. Certificate Transparency Go provides a personality, which is a Golang implementation of a RFC that dictates how to communicate with a CT log. And Trillion handles all of the various Merkle tree cryptographic bits, which is how data is efficiently stored in our database. A particular shard that is actively receiving traffic can grow upwards of 10 terabytes. And we've always relied on MariaDB for our databases. Aside from all these other technologies I've talked about, we run a mixture of Nginx as a reverse proxy, and it performs path routing. We use Prometheus for aggregating metrics and Alert Manager for sending alerts to the SRE team, specifically in the middle of the night to keep them on their toes. It took a lot of hard work to get our logs to where they are, and anything I can do to help alleviate that burden for others, I'm willing to do. Next slide, please. So the active shard will receive a lot of traffic. on the screen, I've got both oak and sapling shards. Oak is the production log used by all the certificate authorities. It receives higher traffic than sapling, even though we try to send all of Let's Encrypt traffic to both to knock it over. In addition to that, the majority of traffic we get is actually not from certificate authorities, but from researchers and monitors and folks who want to see what certificates are actually in our log to see if there's any kind of problems with the certificates or what did Let's Encrypt issue a certificate for. Next slide, please. And so when a researcher comes looking to download certificates from our log, they have to start at the very first certificate and work their way through the hundreds of millions of certificates stored. And that is a huge demand for disk I/O on our database. And it's been the cause of many alerts and several incidents that we've had. So what do we do about it? Next slide, please. One of my colleagues at work named Jacob Hoffman Andrews wrote a wonderful piece of software that we put in front of each CT shard, and we call that CTile. CTile is a caching proxy for RFC 6962 endpoints, and it uses Amazon S3 or an S3 compatible technology as its backing store. Each request that's served from this bucket saves database row scanning operations and allows our log to service more critical traffic. CTile is agnostic to the certificate transparency software used. So as long as the software implements a RFC 6962, it should work. And then we've currently got CTile deployed to sapling, the test log, but it's going out to oak sometime today and tomorrow. And on the screen, you've got an example of what CTile does as far as operations on sapling. It splits between getting from S3 or the database as needed. Next slide, please. So there's costs to running a CT log. Typically, Let's Encrypt spends about 1 to 2 engineers' time about 3 months out of the year just for maintenance, standard upgrades, things of that nature. And it's not all at one time. For compute, what we use in Amazon is basically commodity hardware. We previously ran our logs on bare metal servers. And storage and RAM for those compute nodes just needs to be enough to run the various applications. Now, the database is a whole entire different beast. We started on one single database that we thought was big enough, and that quickly turned out to be not the case. And now we run a distinct database instance, so like a separate VM per shard. And then for CTile, we are hoping that further reduces cost of running our databases, meaning that we can probably scale them down once we get more operational experience with it. And CTile, for both our logs combined, we pay about $300 a month, which is orders of magnitude cheaper than running Amazon RDS. And the last slide, please. This is a bunch of takeaways. I'm not going to read these. You can all review these at your own leisure. But these are some of the helpful things we've learned over the past few years. And with that, thank you all for having me. And back to Antonis.
Thank you very much, Phil. Okay, so you can hear me too. Great. We've seen a few things like about the costs involved. Now I want to emphasize again the necessity of that, because right now there are these 6 companies that are operating logs, and we use these city logs. They are needed so we can find out who's misbehaving and who's issuing certificates and endangering users. We need this data set, and we need these companies to host it for us. However, the problem is that, first of all, it's just 6 companies. So if one or two of them go down, or they decide they want to stop doing this, then we have problems, because the others need 100% uptime. If enough city logs are down, then we cannot issue new certificates. Like, you're going to have to renew your certificates, and the CAs won't be able to do it. The other problem is that it's not a very diverse group of companies, at least by many metrics, and it could be improved. There are certainly things to add to that slide. So we need more city logs right now, and it's one of the reasons we're here, that perhaps some of you can run these city logs and can graciously donate a little bit of time and resources to achieve that. Apple and Google have some guidelines on how to do this and some rules, and the way it happens basically is you download the software, you set it up, you make sure you're comfortable and familiar with everything, and then you tell Google, hey, I've set up this, can you tell me if it works? And then they will just set up an automated tool that will submit things, it will retrieve things, it will try to use all the features. And if, like, after a month or something, they're also happy with what happened, and you're happy and confident that you can run this, then you can make it into this slide. You can be the 7th company in my slides, which is really important. There is also a mailing list, and there is a Slack community where you can join and you can receive technical help as well. People are willing to help you. Let's Encrypt is willing to open source all of that tooling that they built and all the methods they used, and they're happy to talk about all the lessons they have learned operating these city logs to anyone who is interested. So there is a special gift, which is this email address. If you're thinking about doing this in your organization, if you want to know if it's the right thing for you, discuss it with someone, or if you decided that and you want help setting it up, we have a group of people behind this address there, and we're going to try to help you become successful, because we really need the support. We need the hardware, we need ideally the people to run that, and it's critical so we can keep TLS as secure as it is today and ensure that HTTPS still protects the users. If you're a company that offers managed databases or load balancers and you want to prove how good they are, you can show us by running a city log. Just prove to the world that you can do this, and it's also a very nice contribution to keeping the web more secure. If you need anything, that's the email address to contact us, and we'll do everything we can to help. And with that, we can go to questions now.
I see no questions from the floor. James, do you have anything online? No? Okay. I think in that case you have stunned us with your capability.
Always.
And we will say thank you very much indeed, and we'll see you over beer.
Of course. Looking forward.